Here's a second example of how we can model data with a sine wave. So here we have some data from low tide and high tide with the times on 2 different days at a beach. So what we can do is we can graph that with the times, 6 a.m., 12 noon, 6 p.m., midnight, 6 a.m., 12 noon, 6 p.m. So that's evenly scaled on the x-axis. And if we plot these times of high tide and low tide, what we find is that they're pretty much evenly spaced out. And the differences between high tides, 12 hours 13 minutes, 12 hours 38 minutes, the low tides, 12 hours 27 minutes, 12 hours 17, 12:27. I mean, yeah, they're different, but with regards to data collection, it's not really that different. So what we could do is we could talk about an average period. If we take all these times and add them up and divide by 5, what we get is approximately 12.4 hours. And we can say that's going to be the period for our tides. And hopefully, I know I skipped this. This is clearly periodic behavior. It is definitely modelable by a sine wave. I hope you can see that. If not, we got to talk. So what we're going to be coming up with is H equals, H for height, A sine B times T minus C plus D. Now here's a nice thing. Our principal axis is 0, flat water, calm water. That's our normal. So D is 0. If the average period is 12.4, which letter here deals with the period? Is it A, B, or C? I hope you're all screaming out loud, it's C, it's C, it's C. So we're going to take 12.4, the period, equals 2 pi divided by B. 2 pi divided by B. 2 pi, if we shuffle things around here, we get B equals 2 pi divided by 12.4, which in this case is approximately 5.07. 0.507, excuse me. So there's our B value. I've got D, I've got B. Let's talk about the amplitude. Does it tell us how high high tide is or how low low tide is? And it doesn't. All it tells us is that there is one or there isn't one. This graph isn't really measuring height, simply high tide versus low tide. The high tide we're representing by a height of 1. The low tide a height of -1. So A here, A is 1. If we were talking specific heights of the water, depths of the water, this would change significantly. We'd probably need some more data maybe, but we would definitely need to know how high the high tide got and how low it got at the low tides. But since we don't, we're just going to use 1, -1 to represent the highs and lows. Now we need a value for C. Where is our wave going to start? And notice I've marked X right here. Where is X? Well, that X is located halfway between first low and first high. So what we can do is take that 646 time That's equivalent to 6.77 hours. And this first high tide, which was at 1:18 p.m., and that's like 13.3 hours. Notice it's 13.3, not 1 point something, because we're talking about time equals 0 as this 12 midnight. That's t equals 0. So this middle value would be halfway between these two. Awesome. So 13.3 plus 6.67 divided by 2, we get approximately 10. Is it exactly 10? No, but this equation is going to be approximately modeling our data. And we now have all the pieces we need. H equals, A is 1, so sine B 0.507, T minus 10 plus 0. So there we have it, ladies and gentlemen. We are done. We now have an equation that will predict for us when high tide and low tide is on this particular beach. This problem did require some problem solving, some thinking outside the box, but that's going to happen when you have these where it's not just straightforward data points.